Okay, so this video will have checkpoints 1 and 2, which will be on page 448 and 449. So the first example is when you have an exponent with a variable in it, and then the other side is written in a way that we can change it to a power. So we can make these have the same base. So in this case, we'd have 3x minus 6 on this side, and 125 is a power of 5. So I'm going to rewrite that as 5 to the third. If I can change this so it has the same base, that's what I'll do. And now that they have the same base, I can just set the exponents equal to each other, which means 3x equals 9, so x equals 3. So really simple. If you can manipulate the bases, do that so that they have the same power, and then set the exponents equal to each other. Letter B is a very similar question, except you have to change both of them. So in this case, letter B is 8 to the x plus 2 equals 4 to the x minus 3. And in this case, these are both powers of 2. 8 and 4 are both numbers that can be rewritten as a base of 2. So 8 is 2 to the third. So we'll write 2 to the third, and then this exponent will stay the same. 4 is 2 squared. And when you have this, remember one of our very first basic exponent rules was when you raise a power to a power, you multiply those powers. So this becomes 2 to the 3x plus 6. And this one becomes 2 to the 2x minus 6. And now that we have it written as powers of the same base, just like before, we drop the base, set the exponents equal to each other, and solve. I will subtract 6 on this side. I will subtract 2x to this side, so we get x equals negative 12. So that is just a matter of manipulating the bases so that they are the same first, and then setting the exponents equal to each other. I'm going to do checkpoint 2 in the same video. So this goes to page 449. Checkpoint 2, letter A, says 5 to the x power equals 134. Now, obviously, 134 cannot be written as a power of 5. So this is something where we can't do what we just did. So instead, we're going to take the natural log of each side. Remember, that is just an operation. So you can do that to both sides of an equation as long as you do it to both sides of an equation. Now that it's written this way, we can use our power rule, whereas the exponent comes to the front. And once it's in this form, it's really, really simple. To get x by itself, we just divide both sides by the natural log of 5. And that gives us this. If you wanted to give that an actual value, you would just go to your calculator. You would do ln 134 on top, ln 5 on bottom, hit enter, and it would be about 3.043. But you can always check that by just plugging that back into the original and seeing what you get. If I do 5 to the power of 3.043 in my calculator, I get 133.957. So because I had to round, it's going to get you close but not exact. So really easy, just take the natural log of both sides and then simplify.